Hello guys, welcome to VChem World. Today we will discuss on the types of non-ideal solution. It's divided into two parts. First is the positive deviation from Raoult's law and second is the negative deviation from Raoult's law. So first start with the positive deviation from Raoult's law. So Raoult's law says that the PA is equal to PA0 into XA and PB is equal to PB0 into XB. We know that the why this is the same PA is equal to PA0 in XB because of the intermolecular interaction between the A and B, or the solution is the same. But when PA is not equal to PA0 into XA and PB is not equal to PB0 into XB, so this is the violate Raoult's law. Because of the, in this case, PA and PB intermolecular interaction is not identical. So that way its vapor pressure is more or less on the basis of this Raoult's law. So this gives the deviation from the Raoult's law. Whereas the vapor pressure is more, so it gives the positive deviation, and whereas the vapor pressure is less than the basis of the Raoult's law, so it gives the negative deviation. First start with the positive deviation. In the positive deviation, vapor pressure is more than the expected value of the Raoult's law. For example, expected value of the Raoult's law, PA is equal to 0.5 bar. But in this vapor pressure is the PA is equal to 0.8 bar. So that way expected value is a 0.5 bar, but actual value is given is the 0.8 bar. So it gives the positive deviation. Next, draw graph vapor pressure versus mole fraction. Mole fraction is X. Where this is the binary solution. In the binary solution, two component present, solvent and solute. So solvent mole fraction XA is equal to 1 because of this is the pure component, and XB is equal to 1. So this, in this line, this is the pure component. Where pure component exerts this pressure is known as the pure component vapor pressure, or the vapor pressure of the pure component. So XA gives this much value of the vapor pressure and XB gives this much value of this vapor pressure. So these two, A and B, so this is the vapor pressure of the pure component of A and this is the vapor pressure of the pure component of the B. Whereas we go through the left to right. Left to right means that this is the one value, when left to right, so XB value is increase and XA value is a decrease. So XA value decrease comes to the 0 and this is the XB value is 0. Because of the, we know that the total mole fraction XA is equal to XA plus XB. So total value is always 1. Where XA is equal to 1, so XB is equal to 0. When it comes to the left to right, so XB value is 1 and XA value is 0. We know that the Raoult's law says that the where vapor pressure PB or partial vapor pressure of the PB is directly proportional to the mole fraction. It means that the mole fraction decrease, vapor pressure decrease, and mole fraction increase, vapor pressure increase. In this case, XA is equal to 1 means the highest mole fraction and XA is equal to 0, so minimum mole fraction. Where minimum mole fraction, so that means the vapor pressure is minimum. So its graph is the decreasing because of the mole fraction is decreased. In the same case, PB0, this is the highest mole fraction, so its vapor pressure is highest. Then decreasing towards the XB is equal to 0 because of the mole fraction is minimum. So this is the graph. This graph is the partial pressure of A, PA, and this graph is the partial pressure of PB. We find out that the total vapor pressure is equal to P is equal to PA plus PB. So this is the graph of the total vapor pressure. P is equal to PA plus PB. This all graph says that the ideal law of the Raoult's, ideal law. But we discuss on the non-ideal and in this positive deviation. First of all, what is the meaning of the positive deviation? Positive deviation means the vapor pressure is more than the expected Raoult's law value. This is the 0.5 bar and this is the 0.8 bar. That means the PA is more than the PB. How this is the possible? We know that. Consider as a beaker. This beaker is a fill up with the solution A plus B. A is a solvent and B is a solute, and this is the closed vessel. How to define this? This is the positive deviation. In the we know that in the Raoult's law says that the A and B, ideal condition A and B interaction is same. But in this condition, solution is made up of two parts, A and B. So this is the A plus B. And pure component, pure is A and B. This is the separate A and B. Whereas the solution show the positive deviation. In the sense of the positive deviation, that means the vapor pressure is more. First of all, meaning of the positive deviation, that means the vapor pressure is more. How to vapor pressure is more? Why vapor pressure is more? Because of the, in this solution A and B, this bond is weaker than pure component. This pure component A and B. Because of this bond is weaker, or intermolecular interaction between the A and B is weak. When intermolecular interaction is weak, so it's easily converted into its vapor. This is the weaker, so it easily converted into its vapor, and more vapor produced. Easily converted, so more vapor is collected in this place where more vapor present, so its vapor pressure is more. So that way, in this positive deviation, vapor pressure is more. So in this graph is PA, so its vapor pressure is more than the pure component. And this is also vapor pressure is more, and this total PA is more, PB is more, so its total is also more. So it gives the PA is greater than PA0 into XA and PB greater than PB0 into XB. Why this is the possible? Because of the intermolecular interaction between the A and B is weaker than the pure. Because of the, this is the weaker. So that way vapor is more produced, and vapor is more, so its vapor pressure is more. So this is the all about the positive deviation from the Raoult's law. Next we discuss on the example of this. This is the example of the positive deviation. Ethyl alcohol and cyclohexane. First consider is the molecule of the ethyl alcohol connected with the hydrogen bond. So C2H5 oxygen, this is the hydrogen. It's connect with the hydrogen bond. And this is the OC2H5. Whereas this is the 2 electronegative atom, where hydrogen present between the 2 electronegative atom. So it gives the hydrogen bond. One bond has a covalent bond and one bond has a hydrogen bond. So that way this is the form the hydrogen bond. This is the consider as the A. Where so made up of the solution, this is the binary solution made up of the two parts A and B. So this is the A. Where adding B. So cyclohexane add in this the ethanol. So this cyclohexane occupy the space between this molecule. Cyclohexane occupy the space between this molecule. So this bond is breaking. This bond is break. The hydrogen bond is weaker and this bond is also break. So it's more and more weaker. This is the B and this alcohol is the A. So A and B intermolecular interaction is weaker. A and B intermolecular interaction is weaker. This is the pure component A, this is the pure component of the B. But in this solution, this is the interaction between the A and B is more weaker. Where is the A and B more weaker? So it's easily produce the vapor. It's easily converted into its vapor form. Means that the vapor is increased. Where vapor increase, so its vapor pressure is more. So that way, interaction between the A and B is weaker than the pure component A and B. So it's produce more vapor and it gives the more vapor pressure. It shows the positive deviation. Next characteristic of this positive deviation, first characteristic is the delta mixing H. The heat change on the mixing. In this molecule, AA and BB is more stronger than this solution. So we required energy to break this bond, AA and BB bond. Required energy, that means the energy gain by the system. So this is known as the endothermic process. And endothermic means the delta H is equal to positive. So delta mixing H is the positive energy. In the ideal solution, delta mixing H is equal to 0. Because of this is the A and B, intermolecular interaction is the same, or intermolecular interaction is the same. So there is no change in this delta H. But in this is the more stronger than this solution molecule A and B. So it's required more energy to break bond, gives the delta H positive. Second point is the delta mixing V or change. That means the change in volume when mixing. So this is the pure component and this is the second pure component A and B. For example, consider is the 100 ml and this is the 100 centimeter cube. Where these two are mixing, A and B, two mixing, this gives the 220 centimeter cube. It means the 100 plus 100 is equal to 200, but in this case volume is increased. Why volume is increased? Because of in the pure component interaction is more, but in the solution interaction between the A and B is weaker. Where interaction between the A and B is weaker, so it's occupy more space. So this is the occupy more space. That means this volume is more than the pure component. So it shows the delta mixing V gives the positive value. So this is all about the positive deviation from the Raoult's law. Positive deviation from Raoult's law. In the positive deviation, that means the vapor pressure of this A or B is more than the pure component into mole fraction. But in this case, partial vapor pressure of the A is less than the pure component of A and its mole fraction. So it's right that the PA is less than PA0 into XA and PB is less than PB0 into XB. Why this is the occur PA less than PA0 into XB and PB less than PB0 into XB? Because of we know that in the Raoult's law, A and B, component A and B, intermolecular interaction is same. So that gives the PA is equal to PA0 into XB. But in this case, this PA and PB0 vapor pressure is less than the expected Raoult's law. Why this is the less? Because of the attraction between the A and B is more. For example, this is the ideal condition, attraction between the A and B. But in this case, attraction between the A and B more. So it's come closer to each other. This attraction is more. So it's not easily converted into its vapor form. Where attraction more, it's not easily converted into its vapor form. Not easily. So that way, consider this is the beaker. In this beaker, fill up with the solution. In this solution, attraction is more. So it's not easily converted into vapor. That means the collected of this vapor in this place is less. Where vapor is less, so its produced vapor pressure is also less. So that way it shows the negative deviation. Only remember one thing, that where attraction between the two molecules is more, so it shows the negative deviation, and attraction between the two molecules is less, so it shows the positive deviation. Why this is because of the A and B attraction more, so it's not easily converted into its vapor form. Where vapor is not easily formed, so it's not produced that much pressure. That means its vapor pressure is decreased. Where vapor pressure decreased, so it shows the negative deviation. For the graph, this is the vapor pressure of solution versus the mole fraction. In the mole fraction, this is the XA is equal to 1 and XB is equal to 1. Xa is equal to 1, that means the Xb is equal to 0, and this is the Xa is equal to 0. In the pure component, this is the vapor pressure of the pure component, and this is the vapor pressure of pure component of the B. In the ideal condition, where vapor pressure mole fraction decrease, so vapor pressure decrease, that same way, and this is the total vapor pressure. But in this condition, A and B is more attracted to each other, so they not produce that much vapor pressure. So its vapor pressure is less than this Raoult's law expected value. So it shows this way. This is the less vapor pressure. This is the also less vapor pressure, where vapor pressure is a PA is a less and vapor pressure of PB is a less. So total vapor pressure is also less. So this shows the negative deviation from this Raoult's law. Acetone and chloroform. When acetone and chloroform are mixing together, it's form the hydrogen bond. This is the CH3, C double bond O, CH3. This is hydrogen, chlorine, chlorine and chlorine. So this is the formation of this hydrogen bond. In the positive deviation, we saw that the breaking the bond. In this case, formation of bond. Where formation of bond means the attraction is more. In this case, attraction is more. Where attraction is more, so it's not easily converted into its vapor form. Where vapor is a decrease, or vapor value, vapor amount is a decrease, so it's obviously decrease the vapor pressure. So it's so the vapor pressure decrease. And this is the negative deviation example. Next is the characteristic of the negative deviation. First characteristic is the delta mixing H. This is enthalpy change on mixing. When we mix this and this, where the delta H is negative. Why this is the negative? Because of this make the bond. So formation of bond is release energy. So this is the negative, and breaking the bond, it's required energy. So this is the positive. In the positive deviation, bond breaking. Positive deviation, bond breaking. So it's required more energy. So this is the endothermic process. But in this case, bond formation, this is the bond formation. And bond formation is release energy. Release energy means that is the exothermic process. So delta mixing H is a negative, and this is the exothermic process. Next is the delta mixing V. This is the volume change on mixing. For consider is this is the A, fill up with the acetone, CH3, CO, CH3, and second is the chloroform. Where this is the mixing together, and this gives the volume is a decrease. Why this is the volume is a decrease? Because of the in the pure component A and pure component B is a mixing. So it's form bond. Where bond is a forming, that means the attraction is present. Where more attraction present, A and B, more attraction present. More attraction present, so it's occupy less space. It's occupy less space. So our volume is less. For example, consider this is the 100 centimeter cube and this is the also 100 centimeter cube. Where these two are mixing, in this ideal condition it gives the 200 centimeter cube, but in this condition this gives the 180 centimeter cube. Why this is gives the less value? Because of the presence of the attraction between the A and B. So this is the all about the negative deviation from the Raoult's law. On the difference between the positive deviation and negative deviation. On the positive deviation, first point is the attraction between the A and B. This is the less than the pure component. Whereas the negative deviation, A and B attraction is more than the A and B pure component. So this is the first difference. Second is the why this is the produced vapor pressure is a less and positive deviation vapor pressure is a more. Because of the in the positive deviation A and B is a weaker. Where is the weaker bond present? So it's easily converted into its vapor form. Where is the vapor form is more, means that the in this beaker above place is a fill up with the more vapor. So it's produced more vapor pressure. where is the more vapor pressure than the expected value of the Raoult's law. So this is the positive deviation, where the vapor pressure is low than the expected Raoult's law. So it shows the negative deviation. Vapor pressure is low because of the formation of bond or attraction between the A and B is more. Next point is the delta mixing edge. In this positive deviation, this is the positive, and negative deviation, this is the negative. Why in the positive deviation, this is the positive? Because of the, in this case, bond breaking. Where bond breaking, so it's required more energy. More energy required, that means this is the positive value. And in this case, between the attraction A and B, where bond formation, it's required less energy or it's release energy. So this is the exothermic process. In the positive deviation, this is the endothermic process. Next is the delta mixing V. Change on the volume on mixing. In the positive deviation, this is the more or positive because of the weaker, this is A and B. Attraction between the A and B is weaker, where this bond is weaker, so it's occupy more space. It's occupy more space, so its volume is increased. But in this case, A and B, attraction is less. Where attraction is less, this attraction is less, so it's occupy less space and its volume is decreased. So this is all about the positive and negative deviation from the Raoult's law. Thank you.